Okay, so Leetcode practicing. The first goal in this video is to see how to solve this problem, and then we are going to do some coding work. And the second goal is to see how we should behave in real interview. So let's get started. So in a real interview, the first step is always to try to fully understand the problem. If there's anything unclear, please bring up the question, and at the same time, think about some edge cases that can potentially break the general algorithm. So let's see. So in a given array nums of positive integers, find the three non-overlapping subarrays with maximum sum. So each subarray will be of size k, and we want to maximize the sum of all 3k entries. So return the result as a list of the indices, representing the starting position of each interval. So if there are multiple answers, return the lexicographically smallest one. So suppose the input is like this, 12126751 as input array, and we have the k as 2, then we are going to return 035 because those three subarrays has the largest sum. Okay, yeah, I think I mostly understand the question, and let's see the constraints. So it says that the input array is now going to be empty, and the number will be positive, and k will be between 1 and floor nums length divided by 3. Okay, so it means that the length of the nums is always going to be larger or equal to 3k. Okay, so I think based on the constraints, I think we don't have some edge cases to be considered at this time because all the input cases are legal. So let's see how to solve this problem. The next step is about finding a solution. So how to solve this problem? I would say, first of all, we need to generate a sliding window sum. So for example, for this input, we will have a fixed length of the sliding window, and we move the sliding window towards the end, and at the same time we are going to compute the sum of all the numbers within the sliding window. So like this, let's call it like SD sum. So for this one, for the first number, because we only have one number, we just have it as just that one. And for when sliding window moves here, then we are having two numbers, which is we are having two numbers. So the current sliding window sum is equal to 3. And then we further move the sliding window here, so it is going to be 3 as well, and so on and so forth. So we are going to have 1, 3, 3, 3, and then 8, 13, 12, and 6. So we will have the SD sum something like this. So after having the SD sum, I think we could apply some brute force search to enumerate all the possible indices of the subarray, and we just use the SD sum to compute the sum of the three subarrays. So that would be a workable approach. However, I think it's asking about 3 non-overlapping subarrays. So it must have something to do with this special number 3. So the special number 3 makes me feel like we could use like 2 pointers, the left pointer and right pointer, and we had the middle pointer. So some general direction like that. But let's see how we could make it more specific, make the idea to be more specific. So let's see if let's define an array, let's call it left max. So this array is going to record until the current index what would be the index of the SD sum that comes before the current position that has the largest value. So for example, left max, first one is 0, and then the second one is 1, 1, 1, 0, 1, 2, 3. Let's use some. Yeah, let me write down the indexes of the array. 5, 6, and this is 7. So it will be something like this regarding the left max. Let me further explain what is left max. So left max is essentially saying until the current index, what is the index within SD sum that has the largest SD sum value. So for example, for this one, it is equal to 4. That's because, for example, let's say this one is equal to 5. The reason it is 5 is because among all the indexes, including the current index within SD sum, the number at index 5 in SD sum that has a maximum value. So that's essentially what the left max is. And similarly, we can generate the right max, which is just a reverse representation of the left max. So we start at the end, so it will be, first of all, it will be 7, and then it is 6. Yeah, there's a 6, and then the 5, and then all the previous ones are 5. So we have 5, 5, 5, 5, 5, 5. Let's see how many 5 do I have. So yes, so we have 5 as for now. So similar representation, the right max means starting from index, starting from the current index, what would be the index within SD sum after this index that has a maximum value. Yeah, so that's pretty much about left max index. And then what we are trying to find is we should have a middle index. We have a middle pointer. Let's say the middle pointer is going to start from 2k minus 1 to n minus 1 minus k. So in this case, we are going to look at those three things. So we are going to have let's say the made is from 2k minus 1 to n minus k minus 1. So from made, we are going to what we are trying to compute is the SD sum made plus SD sum pointed by the left max made minus k. It should be left max made. If it is left made minus k, left made minus k means the maximum ending with made minus k. Yeah, I think it's right. And SD sum, this is right max of made plus k. So this is essentially saying this is about the sliding window sum from made minus k plus 1 to made. This is the range the range sum of that. And this one is essentially saying ending with made minus so it's going to get left max made minus k, the indexes of the SD sum. So left max made minus k, it represents ending with made minus k. What would be the maximum number within the SD sum that has a maximum value until made minus k? So similarly, we are doing this one. We are going to plus the third subarray. So we are trying to find the maximum with it for this, and when we find the maximum, we can get the corresponding index and then further assign it and to be returned. So that's the general idea how to solve this problem, and the runtime in total is going to be all of n. So n is the length of the input array. So next part, after you communicate with your interviewer about the solution, it's time for us to do some coding. So for coding, we care about the correctness, readability, and also don't be too slow. So let's give it a shot by doing some coding work. So first of all, we are going to compute the sliding window sum. So let's say SD sum as equal to new int nums.length minus 1. So int I is equal to 0, I is smaller than nums.length plus I. Let's get a sum, which is a temporary local variable. Sum plus equal to nums I. So I would say if I is larger or equal to k, then we need to have some minus equal to nums I minus k. Then we are going to have SD sum I as equal to sum. So after you compute SD sum, it's time for us to do computation about the left max. So you're going to have left max as equal to new int length minus 1. So let's say we have the int I is equal to 0, I is smaller than nums.length minus 1, just a smaller equal to length plus I. So we are going to have, so we need to define like a largest IDX starting from 0. So you have if nums I so if SD sum I, if it is larger than SD sum largest IDX, we are going to have largest IDX is equal to I. Sure. So we are going to have the left max I to be set as largest IDX. And similarly, we are going to define the right max as new int nums.length minus 1. Then we set, let's set the largest IDX as nums.length minus 1. So we are going to iterate through it, but this time we start from the end. So let's say int I is equal to nums.length minus 1, I is larger or equal to 0 minus I. So if SD sum I is larger than SD sum largest IDX, so it is asking us to return the lexically smallest one. So it should be larger or equal. So if it is equal, we still need to have the largest IDX set as I. So it would be right max I would be equal to largest IDX. Alright, so after we have the right max and the left max, is for us to compute this part. So you're going to have, let's say, array at, let's say, array idx is equal to new int 3. Let's say the max sum is equal to -1, let's say. So int made starting from 2 times k minus 1, then made is smaller than, so it's a range of nums.length minus k and plus made. So first of all, we are going to get so int left, it would be so the left max of made -1 and minus k, and then the right index is right max of made plus k. So if it is yes, and then we have the sum as equal to so the sum is equal to, let's say it is equal to the SD sum left plus SD sum made plus SD sum right. So if sum is larger than the max sum, then you're going to have max sum as equal to sum, and then we need to have the set to the left as equal to the, so we are going to have arr idx as 0, set as left. So because the left is the ending index actually, so we need to have it minus k plus 1. And so similarly, we are going to have the made index and the right index. So this is made, this is right, and finally we are going to return the arr idx. Yes. So that's pretty much about the coding, and it's time for us to do some testing. For testing, let's just reuse the same the same input case. Let's check the first piece. So the first piece is about calculating the sliding window sum. Let's call it SD sum. So first of all, SD sum is equal to, so the first one, it's just the first number, which is 2, and the second one, it is equal to 3, and the third one, because it is I is larger than it's equal to k, so you're going to after e plus 1 we need to minus this one, so it's going to be 3 as well. So on and so forth, we are going to get the SD sum like this. And then we compute the left max. So the regarding the left max, so for the left max, it will be, yeah, so left max, first of all, okay, so let me, left max is equal to, first of all, we say that so it is when I is equal to 0, then it is not larger, so we are just going to have largest index as 0. Then for the next one, SD sum is 3, which is larger than 1, so we are going to have last max as 1. And similarly, this one is equal to 1, and this one is equal to 4. So on and so forth, we are going to get the left max as what we just calculated. And the next step is about calculating the right max. So for the right max, we start from the last element within the SD sum. So if the SD sum is larger or equal to that, then we are going to, so for the last number it will be 7, and for the next one, because 12 is larger than 7, so we are going to have largest index as 12, largest index as 6, so we are going to have right max, this is 6 as 6. So similarly, we are going to have the right max as this after this piece of code, and then let's see. Then we are going to run this piece of code, which is about the final step to find the maximum 3 subarrays. So we start from, okay, so let me just close those pieces. So first of all, made is, so the made is between 2k minus 1, which is 3 to 5. So we have three things, three values to iterate. Made could be 3, 4, or 5. So if made is 3, then we have left as so the left would be equal to, so 3. So first of all, left, made, and right. Left is so made is 3 for sure, and the max is made minus k. So we are going to have left max 1. So what is left max 1? Left max 1 is 1, and the right max 5. Right max 5 is 5. So we compute the sum. It would be 3 plus 3 plus 3 plus 6, 13. So now it is 19 in total. So currently the max sum is equal to 19, and the result is 0, 2, and 4. And when the made is 4, the left is equal to left max 2, which is 1, and right max 6 is just 6, so it is this. So we see the 1 is, SD sum 1 is equal to 3. So this is 3 plus 8, 3 plus 8, which is 11, then 11 plus 12, which is 23. So now it's 23 for the this. Then we are going to have this set as 1, 2, 1, 3, and 5. Then when made is equal to 5, then when made is equal to 5, we are trying to see left max 3, which is 1, and the right max 7, which is 7. So currently the sum is equal to 3 plus 13, which is 16. Currently 16 plus 6, which is 22. So it is smaller than max sum. So we finally return 135. Alright, so I think this piece of code should work. Let's give it a shot by running it. So let's run it. Sum. Alright, so sum is already defined. Okay, okay, we just use it here. So it says index 3 out of bound. So SD sum why? So SD sum, oh, okay, so I think I made some mistake here. It's a typo. Nums, so it says left, oh, why I initialize everything to be -1. That should be definitely a typo. Okay, so now it works. Let's do a summation. Okay, so I think everything looks good. So this is a whole piece of code. If you have any question about the solution or about whatever, feel free to leave some comments below. And if you like this video, please give me a subscription, and I'll see you next time. Thanks for watching.